Down there, life continues. The traffic is awful, stocks go on trading, and Star Trek is still showing.
day, grade 8 learners. Welcome to today's natural sciences lesson. My name is Patricia Singo, and this lesson is proudly brought to you by the Harding Department of Education. In today's lesson, we're going to be learning under the knowledge area, matter and materials. The topic is still atoms, but the subtopic, which is our main area of focus for today, is compounds. So we're going to learn much about compounds today. So let's go through the lesson objectives together. So at the end of the day, you should be able to define a compound, represent compounds as fixed ratios, and explain how a compound is formed. Then lastly, describe how a compound can be decomposed. All this is sourced from your CAPS document on page 11 and page 40. Now, let's go through pre-knowledge. So this is what we've learned prior to today's lesson. So it has basically laid the foundation for today's lesson. In the 7th grade, remember, we did learn about properties of different materials. For example, melting points, boiling points, electrical conductivity and heat conductivity. And then so far in the 8th grade, we learned about elements, the names of them and their symbols as well. Now, let's go through our baseline activity. So I'm going to read out the questions for you and then give you time to answer them. So the first question reads, what is an element? And then the second question says, draw models to show the atoms that make up molecules. A, oxygen, B, water, and C, hydrogen. Give yourself 4 minutes. I'm going to give you 4 minutes to answer these questions, and then after 4 minutes, we are going to do the solutions together. Don't forget to send in your answers to the WhatsApp number at the bottom of the screen. So see you after 4 minutes. Welcome back, learners. Don't forget to send in your responses and any questions you may have to our WhatsApp line, which is 079 578 and 2908. Now let's answer the questions together. What is an element? What is an element? An element is a material that consists of atoms of only one kind. And then you're also required to draw models to show the atoms that make up molecules, oxygen, water, and hydrogen. Remember last week we learned that some elements, some atoms of some elements exist as diatomic molecules, and oxygen is one of them. So there is oxygen, and then we have water. Remember, water was one example that we also gave in our last lesson as a pure substance, that sometimes pure substances come as molecules of compounds. So there we go, where we have a molecule of a compound that makes up water with two hydrogen atoms and one oxygen atom there, and then we have hydrogen. Hydrogen also exists naturally as a diatomic molecule, which means it's two. We have two hydrogen atoms that are bonded together. So take 1 minute to quickly copy down these corrections, and then after 1 minute we will continue with our lesson. Welcome back, learners. Now let's move on to our terminology slide. So these are the terms that we are going to be using in today's lesson, and they'll help us better understand the different concepts that we are going to learn today. So let's find out what the terms are and what they mean. So we have compound, a material that consists of atoms of two or more different elements chemically bonded together. So when we have two or more different elements chemically bonded together, that is what we call a compound. And then chemical bond. Chemical bond, this is the force that holds atoms together in a molecule, the force that holds atoms together in a molecule. And then chemical reaction. Chemical reaction, this is a process in which atoms of elements or compounds, they rearrange themselves to form new compounds or elements. Now let's go through the second slide with the terms. Decomposition reaction, quite a mouthful, isn't it? Right, so a chemical reaction in which a compound is broken down into simpler, it could be a simpler compound or a simpler element. So this is when we are breaking down a compound. And then electrolysis, this is the decomposition of a compound when an electrical current is passed through a solution of the compound, when it is passed through a solution of the compound. So now we are done with our term. Now let's learn about compounds. Right, a chemical bond is a force that holds atoms together. So we learned that a compound is formed when in a chemical reaction, and in a chemical reaction a chemical bond is formed. And what does it do? It holds atoms together. So we've got two atoms there. We've got sodium and chlorine. They are being held together by what is called a chemical bond. And then we also have one example here of water, a water molecule. Remember, a water is a molecule of a compound. Then where we have two hydrogen atoms that are chemically bonded together. And here our chemical bond is being represented by this line here. So this line here represents the chemical bond, the force that holds this hydrogen atom together with this oxygen atom. And then this bond here is holding this hydrogen atom together with the oxygen atom. So that is a chemical bond. Now, chemicals, or rather atoms, react chemically to form molecules of compounds. We've already defined a compound as a material that consists of atoms of two or more different elements that are chemically bonded. So a compound, remember we learned about diatomic molecules. We said diatomic molecules, this is when we have atoms that belong to the same element being chemically bonded together. Now, with compounds, the material consists of atoms of two or more different elements. So the elements are different. Here are some examples of compounds. The first one is water. Water is a compound. Why are we saying water qualifies as a compound? Water qualifies as a compound because we have got atoms of two different elements. We've got atoms of hydrogen and we've got an atom of oxygen. So these are two different elements. And then we've got carbon dioxide. Remember, C is the chemical symbol for carbon, right? And then this carbon atom is bonded to oxygen atoms, forming a compound, and this compound is called carbon dioxide. It is called carbon dioxide. We have an atom of carbon bonded to two atoms of oxygen. And then the next one is sodium chloride. We've got, remember, Na is the chemical symbol for sodium, and then we've got Cl for chlorine, and then the compound name is sodium chloride. That's the name of the compound. The compound consists of two atoms, one atom belonging to sodium and the other atom belonging to chlorine. That's why we are writing it like this. That's the chemical formula. So these are the chemical formulas and these are the names. These are the names of the compounds. So here are the examples of these compounds in real life. Water, the chemical formula for water is that one, H2O, just to tell us which elements are found in that compound. We know what water is. We drink water, we use it to cook, we use it to wash, we use it to do a lot of things. And then carbon dioxide is one of the gases that are found in the atmosphere. Remember when we're learning about photosynthesis and the requirements for photosynthesis, and carbon dioxide was one of them. And then sodium chloride, or commonly known as salt. So this is the salt that we use to give flavor to our food or to preserve our food. And the scientific name or the chemical name for salt is sodium chloride, the common table salt that we all use. Okay. Now, an atom in each compound is always combined in a special way. It is always combined in what is called a fixed ratio. It is always combined or bonded in what is called a fixed ratio. So here when we're talking about compounds, we know that our compounds, each atom in our compound is in a fixed ratio. I have two examples. My first example is carbon dioxide. Remember we said carbon dioxide whose chemical symbol is CO2, right, consists of one carbon atom and two oxygen atoms. Right, so this one carbon atom, there it is, and then we have our two oxygen atoms. So we say fixed ratio. Each and every carbon dioxide molecule of a compound has this ratio. It is always one carbon atom bonded to two oxygen atoms. So the carbon dioxide molecule consists of one carbon atom bonded to two oxygen atoms. So what is the ratio? The ratio is 1 is to 2. One carbon atom bonded to two oxygen atoms. And then our second example, which we've been using quite a lot, is the water molecule. The water molecule, it consists of two hydrogen atoms that are bonded to one oxygen atom, thereby giving us a ratio of 2 is to 1. Where is the model? Here's the model. There's one hydrogen atom, and then there's the second hydrogen atom, and then they are both bonded to the oxygen atom. These lines represent what? They represent the chemical bond. What is the chemical bond? The chemical bond is the force that holds atoms together, be it in a molecule or in a molecule of a compound. So in a compound, the atoms are always in what is called a fixed ratio. You need to remember that. So they are always bonded in a fixed ratio. So you always find the water molecule in a ratio of 2 hydrogen atoms is to 1 oxygen atom. The fixed ratio for carbon dioxide being 1 carbon atom is to 2 oxygen. So compounds such as water, carbon dioxide, and table salt, which is sodium chloride, are formed by chemical reactions. Do you remember what a chemical reaction is? A chemical reaction is a process in which atoms of elements or compounds rearrange themselves to form new compounds or elements. So I've got an illustration here just to show you what I mean by what is a chemical reaction. So we have got two molecules of elements here. We've got here on the white, and then we've got here on the red. So we'll just call these A and B and C. Now, if we look at the molecules, or rather the elements from A, the ones in white, so we've got two of those, and then we've got a pair here, or a diatomic molecule of B. So we've got two diatomic molecules of A, and we've got two diatomic molecules of B. So now, in the process of a chemical reaction, remember we said it is a process, the atoms of elements rearrange themselves. So this arrangement that we have on this side, on the left hand side, the arrangement that we have on this side is going to change. The atoms rearrange themselves and give us product C, which is the new compound, so product C. If you compare the left hand side of the arrow and the right hand side of the arrow, you can see there is a huge difference on how the atoms are arranged, or on how the atoms are bonded to each other. As you can see, one atom that belonged to B is now combined, or is now bonded to two atoms that belong to element A, and then another atom that belonged to B is now bonded to two atoms that belonged to A. So there has been what is called a rearrangement. So that's what happens during a chemical reaction. The process involves atoms of elements rearranging themselves to form new compounds, or new molecules. Now, compounds have different properties. And remember, compounds are made of elements. So compounds are bound to have their own specific properties that belong to them. And these properties are different from the properties that make up the compound. For example, sodium, chlorine, and sodium chloride, these are very different. This is an element. It has its own properties. It has its own melting point, boiling point. It has its own other physical and chemical properties. And then chlorine. Chlorine also has its own special properties that identify the element as chlorine. Sodium chloride, now we've come to something different. This is a compound. This is a compound. This compound, we have learned from the previous slide that sodium chloride is made up of an atom of sodium and chlorine. But sodium chloride is very different, or reacts or behaves different from the elements that make it. So sodium and sodium chloride, they both conduct heat, which is a physical property, right? Whereas chlorine does not. You see the differences. There are other differences as well. Chlorine in its natural form doesn't look like this white powder that was seen there when you physically look at it. There are other properties as well. For example, if you burn sodium, it's going to give you this flame, this bright yellow flame that is blue at the bottom. If you burn chlorine, it's going to give you this bright white flame. But if you burn the compound sodium chloride, you will get this deep or rather dark yellow orange colored flame. So the compound's properties is very different from the properties of the elements that make up the compound. So you see, different elements and compounds have different properties, regardless of whether what combination you end up with which element. Okay, now we're going to do an activity, and this activity requires you to use the periodic table to answer the questions. So here are the questions. Now, number one, how are the atoms held together in a molecule? Number two, the table below shows the different gases that are found in dry air. We have nitrogen, carbon dioxide, argon, and oxygen. So using the table, you need to answer the following questions. 1. Give the name and chemical formula of a molecule of a compound. Give a fixed ratio of elements which make up carbon dioxide. And then number 3, give an element that normally exists as a diatomic molecule or molecules. Right, so take 5 minutes to answer these questions. Don't forget to send in any questions you may have and the responses to these questions to our WhatsApp line, which is 079 578 2908. So see you after 5 minutes. Welcome back, grade 8 learners. Now let's answer the questions together. The first question read, how are atoms held together in a molecule? They're held together by a chemical bond. Remember, we said a chemical bond is the force that holds atoms together, be it in a molecule or in a compound. And often these chemical bonds, let's say in a picture or in an illustration, they are represented by a single line, or it could be a double line or a triple line. And then question number 2, we're using the table and the periodic table to answer the questions that followed. The table below shows the different gases that are found in dry air. We've got nitrogen, we've got carbon dioxide, we've got argon and oxygen. So these are the different gases that are found in dry air. Now, you needed to use the table to answer the following questions. So the first question read, give the name and chemical formula of a molecule of a compound. So amongst these one, which one is the molecule of a compound? Is it nitrogen? Is it carbon dioxide? Is it argon or is it oxygen? It is carbon dioxide. And what's the formula? It is CO2. So take 1 minute to copy down the corrections, and then after that we'll continue with the other 2 questions. Welcome back. Now let's answer the second question. So we were required to give a fixed ratio of elements which make up carbon dioxide. A fixed ratio. So the ratio is 1 carbon atom is to 2 oxygen atoms. Right, so I included a model in the corrections just to explain the ratio. So carbon dioxide consists of these elements. It consists of oxygen and carbon. And then the fixed ratio, or rather the fixed ratio of the elements that make up carbon dioxide is 1 carbon atom, which is this one in the middle, is to 2 oxygen atoms, where we have one on this side and another one on that side. Take 1 quick minute to quickly copy down the ratio and the model as well. Welcome back. Now the last and final question from the table, select an element that normally exists as a diatomic molecule. Is it nitrogen, carbon dioxide, argon, and oxygen? Of course, it is oxygen and nitrogen. Remember, in our previous lesson, we learned that these two exist naturally as diatomic molecules. Right, argon belongs to the inert gases, and then carbon dioxide is a molecule of a compound. Now let's move on to decomposing compounds. Decomposing compounds. Now compounds consist of different elements that we have established. So because they are made up of different elements, it also means we can break a compound down into its original or their original elements by these two methods. So this is a picture just to show us breaking down a compound. We can either use heating, or we can use electrolysis or electrolysis to break down a compound. Now, this process of breaking down a compound has a special name. Its name is decomposition. So, this process is called decomposition. A decomposition reaction is a reaction that is opposite of what happens when a compound is formed. So in this particular instance, we are breaking a compound down into its original elements, either by heating or by electrolysis. So now let's explain how these two types of decomposition reactions happen. Now we've got electrolysis decomposition, right? This one is when we use an electric current, and then we've got heating or thermal decomposition. This one is where we use heat or higher temperatures. So this one will represent electrolysis by decomposition, and then this one is heating by thermal decomposition. As you can see, there's our source of heat. Okay, so now let's learn deeper about these two. Let's learn more about these two. Electrolysis or electrolysis. Electrolysis is a process where we pass an electric current through a solution of a compound to break it up into other elements. What do we mean through a solution of a compound? For instance, if you want to make a solution of sodium chloride, we dissolve sodium chloride in water, and then we make a solution of sodium chloride. Now, electrical energy is what we need to split up a compound into the element it is made from. For example, if you pass an electric current through water, you can split it into hydrogen and oxygen. Remember, each water molecule has 2 hydrogen atoms and has 1 oxygen atom. So if we pass an electric current through water, we can be able to split that compound into hydrogen and into oxygen. How? Electricity breaks the bond in the water molecule. So the electricity is capable or is able to break the bond between the water molecules. So we have water here in this trough, and then we pass an electric current, our source of power, of course, being the battery. And then we have our products, oxygen gas and hydrogen gas. They just by simply passing an electric current through them. Now, the second method of thermal decomposition is a decomposition reaction where we are going to use heat energy. We introduce heat energy in order to break down a compound into the elements that it is made of. That's how we do it. For example, potassium permanganate, so this is the chemical formula KMnO4, decomposes into its elements by heating, and one of the elements that are produced here is oxygen. So what happens is the compound is placed in this test tube. It is heated, so that's our source of heat to break down. So the heat will break the bonds, the chemical bonds that exist within this compound, breaking them. And then once the bonds are broken, then we have our different elements. Now, which brings us to our second activity. I'm going to read it out to you. 2 spoons are connected to a battery and placed into a glass water. Number one, what will you observe in the glass after a while? Number two, will this experiment work if you replace the spoon with wooden sticks? And then write down a chemical equation for the reaction in the glass. And then when the water is boiled, you can also see a gas at the top of the kettle. Is this also an example of the decomposition of water? So give yourself 5 minutes to answer these questions. Then after 5 minutes, we will go through the solutions together. Welcome back. Now let's answer the questions together. Like, what will you observe in the class after a while? You observe bubbles from oxygen and hydrogen. Remember when we were giving our example of the decomposition of water, we observed, we talked about seeing oxygen and hydrogen gas bubbles. Now, will this experiment work if you replace the spoons with wooden sticks? No, it will not work because wood cannot conduct electricity. Remember when we're learning about the properties of different materials, others can conduct electricity and others cannot conduct electricity. And in this particular experiment, we require a material that can conduct electricity. And then what is the equation? What is the equation for the breakdown of water? It will be water to give us hydrogen and oxygen. And then number 4, when water is boiled, you can also see a gas at the top of the kettle. Is this also an example of decomposition of water when you see the gas that's at the top? No, it is not. You do not see hydrogen and oxygen, but small water droplets that are condensing. Between the steam that you can see and the kettle, there is water gas, which you cannot see, but it is not hydrogen and oxygen, because when we are boiling water in a kettle, we are heating. We are adding heat energy to the water. We are not passing an electric current through the water. So those two are quite different. Now take 2 minutes to quickly copy down the corrections. Then after 2 minutes, we will wrap up our lesson. Welcome back, learners. Now let's wrap up our lesson. So today we learned about compounds. We learned that a material that consists of atoms of two or more different elements chemically bonded together is what we call a compound. And we gave examples of compounds. We gave an example of water. We also had carbon dioxide and sodium chloride. And then we learned that compounds are formed by what are called chemical reactions. Do you remember what a chemical reaction is? This is a process where atoms of different elements, they rearrange themselves to give us new products. And that new product will be the compound. For example, when carbon dioxide is formed. We have atoms that belong to carbon combining or being bonded with atoms that belong to the element oxygen to give us the compound carbon dioxide. So that is a chemical reaction. Right, how are these two held together? They are held together by a force, and this force is called a chemical bond. So a chemical bond is the force that holds two atoms together, be it in a molecule or in a molecule of a compound. Right, so this is how compounds are formed. Compounds, because they are made up of atoms that belong to different elements, they can be broken up. And how are they broken up? They're broken up by what is called a decomposition reaction. That's how they are broken up. Now, atoms, we know, we've been learning about atoms so far, that they are the basic unit of matter, the different subatomic particles that make up atoms, and that atoms of different elements are different. Now, the atoms are capable of reacting together to form what are called molecules of compounds. They are capable of chemically reacting together to form molecules of compound. That happens during a chemical reaction. And then atoms in a compound, this is very important, atoms in a compound are they are always combined in a fixed ratio. They are always combined in a fixed ratio. You always find water with 2 hydrogen atoms and 1 oxygen atom. Now, what's the ratio here? It will be 2:1. With this compound, what is the ratio? It is 1:1 because we have 1 sodium atom chemically bonded to 1 chlorine atom, and then in carbon dioxide, our ratio would be 1:2. We have 1 carbon atom is to 2 oxygen atom. Now, let's remind ourselves again about how compounds are broken down. So we briefly touched on how compounds are broken down in the previous slide. So we said a decomposition reaction has to happen in order for us to break down a compound, whether into its elements or into other compounds. For example, we have 2 here. We've got one method here and another method there. Do you remember the names of these methods that we use to break down compound? This is electrolysis, where an electric current is passed through this solution of the compound that we want to break down. For example, here we've got water, and electric current is passed through the water to give us oxygen and hydrogen. And then we have here the second one, where we're going to use heat. Heat energy is introduced, or rather the compound is exposed to heat, then it breaks down to its element. We gave an example of potassium permanganate, that when you heat it, you decompose it into its elements, and one of them is oxygen. One of them is oxygen. That is one of them. Right, in our next lesson, we're going to be learning about mixtures of elements and compounds. Here is the homework activity that I need you to copy down. Number 1, the process in which substances undergo chemical changes that result in the formation of new substances called blank, and then the force that holds atoms together is called blank, and a chemical reaction that breaks down compounds into simpler compounds is called blank. Take 2 minutes to copy down these questions, and then after 2 minutes, we will end our lesson. Welcome back. Now, thank you so much for joining me in today's lesson. I hope to see you in the next one. Goodbye.